All right, guys, for today's lesson, you're going to need page 12 out of your packet. So, again, this is page 12 out of your packet, right where we left off. We're going to skip down to problem number 7. So, let's go ahead and look here. Number 7 says Doug is pouring cement for his backyard patio that is 100 square feet. The cement comes out of the truck at a constant rate. It is very important he gets all the cement poured before 12 noon when it gets too hot for the cement to be mixed properly. It is currently 11 a.m. and he has poured 75 square feet of concrete in the last 3 hours. At this rate, will he finish before noon? So the important thing here is that we see this constant rate. And that constant rate is what we're dealing with lately when we graph things. As was also talked about, like our unit rate. So it's this rate that's not going to change. It's going to be consistent throughout the entire problem. Okay, so part A says fill in the missing items in the table. If X is the number of hours that have passed since he began pouring concrete, and Y represents the total amount of concrete poured. So at 0 hours, it makes sense that he hasn't poured anything. So there's 0 concrete poured at 0 hours. And then we look down and we see, well, there's 1 hour, 2 hour, 3 hours. And at 3 hours, it's 11 a.m. And he's poured 75 square feet. So if I wanted to figure out what the constant rate was, I would take my y and divide it by x. So my y divided by x, 75 divided by 3, and that gives us 25, which means there's 25 square feet per hour. Okay, that's what his rate is. The constant rate is 25 square feet per hour of concrete that's being poured, which means at 1 hour, I know it's going to be 25 square feet because we just talked about that. And then at 2 hours, we can see, well, 25 and 25 is 50. And then at 3 hours, we had the 75. So at 4 hours, I would just add on another 25 to be at 100 square feet. And we see that he's pouring cement for his backyard patio. It's 100 square feet. And we see at the 4th hour, he gets 100 square feet. So the question was, at this rate, will he finish before noon? And I guess that could be interpreted a couple different ways. But the way I look at it is he's not going to finish it until exactly at noon. Because the 4th hour, that's when he gets 100 total square feet poured. So at 11:59, he wouldn't quite have the 100 feet. He might have like 99 point something. So I would say no, he will finish at noon. So he's going to finish the job at noon, not before noon. Okay, next we need to graph this. So here you got to remember that our x-axis is always the horizontal, and the y-axis is always the vertical. Okay, so we got our axis labeled, and now we need to go ahead and put labels on the axis with what it means in terms of the problem. So you see our x is time. So time, and it's even like hours. So I'm going to say hours. And then my y is amount of concrete square feet. So I'm going to say over here, I'm going to say square feet of concrete. So whenever we're graphing real world problems, we need to put labels on our axes that have to do with the problem to give it some context. Okay, in this corner is always going to be a 0. Okay, then now let's look at the hours. We see I need to go from 0 all the way up to 4. And you see here, if I go by ones, there's plenty of room here. So I'm just going to label there's 1, 2, 3, 4, and 5. And then I need to get all the way up to 100. So I'm going to count the boxes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, which makes it very easy. We can just say every box is 10. Okay, so we're just making our scale for these graphs. So I'm counting by tens. Okay, next we're going to go ahead and graph these. So I'm trying to find a different color. And at 0 hours, it was 0 concrete poured. At 1 hour, it was 25. So you'll notice there's not a 25 on here, but we can go at 1 hour and halfway between 20 and 30 and make my 25. At 2 hours, we have 50. So I'll go all the way up to 50. At 3 hours, we're at 75. So I'll go up to 70 and then halfway between 80, so 75. And then the last 4 hours, we're all the way up to the top at 100. Okay, use your straight edge. You must use a straight edge when we graph. And we're going to go ahead and connect those points. Okay, now I do need to put an arrow on the end of this one because to show that this pattern would continue, because at the 5th hour we could predict where it's going to be if we made the graph larger, 6th hour and so on. So I put the arrow on to show that that pattern would continue. Okay, turn the page. So letter C asks, what is the unit rate for this relationship? In other words, how many square feet of concrete can Doug pour in 1 hour? Well, we already talked about that before, and that was that unit rate that we said 25 square feet. And I put that slash is often read as per hour. And that means per 1 hour. Okay, the unit rate is always compared to like one of something. You don't want to know like how many feet in 2 hours or how many feet in 5 hours. They want it compared down to like feet in 1 hour. So 25 square feet per hour. Okay, now the equations. For our equations when we graph, they're always going to start off with a y equals. Okay, so these are always going to be y equals. The x equals is a special circumstance that is not going to be part of this one. So this is x equals I can get rid of. And what comes next is my unit rate. So my unit rate I see is 25 square feet per hour. And that's going to be represented by the number that's in front of x. So 25. And then you put the x on, which x represented the number of hours. So 25 feet times the number of hours gives you y, which is the total. So that's going to be letter A.
Good morning. Happy Wednesday. There are bagels, cream cheese, and coffee in the lounge for your enjoyment. Have a wonderful day.
Letter E, will Doug finish the job in time? Well, we already kind of talked about that briefly as well. I said no. He will finish exactly at noon. If they expect him to finish before noon, it's not going to happen. But if they wait all the way till noon, then he will have it done. Okay, number 10. Vanessa's mixing formula for her baby. The graph given to the right describes the relationship between the ounces of water to the scoops of formula to make a properly mixed bottle. So here we have our x-axis. Our x-axis labeled as scoops. Our y-axis is labeled as ounces. And we have the appropriate numbers there. Looks like it's going 1 for 1. 1 scoop. Then we have every box of there counts for 1, as well as the ounces. So, does the graph represent a proportional relationship? Okay, so proportional relationship means a couple things. 1, does it start at 0? Well, yes, it starts at 0. 2, is it a straight line? Yes, it's both of those. So we say yes starts at 0 and is a straight line. Okay, what is the unit rate for this relationship? Okay, so if you look here, I want to see like one of something, and it's kind of hard to see where this is a partial box. So I'm going to go all the way to here. And this is the first time I see that the line goes through the corner of a box. Okay, now remember our unit rate is always the y over the x. So my y value here, if you look at it, it's at 3, which represents 3 ounces. Okay, and at 3 ounces, that's 1 scoop. And again, we are talking about formula, so between water and scoops of formula. Okay, so that's like, maybe I'll even say 3 ounces of water. And that's already compared to 1 of something. So this is my unit rate, 3 ounces of water to 1 scoop. Okay, at a different location on the graph, show and explain how you can find the unit rate. So we picked that one. Well, let's go all the way up till we see another corner of a box. And there's a couple. There's like one right here. There's one right here. There's some further up there. So let's say I choose this one here. Okay, so we'll come down there. And that one, again, take your y over the x. So that's 9. And again, that's 9 ounces of water over, and we see right here 3 scoops. You do want to reduce always. So 9 over 3, we know reduces down to this 3 over 1, because 9 divided by 3 is 3, 3 divided by 3 is 1. So even though I picked this point, it's going to reduce down to 3 over 1. If I would have picked this point, we see you would have had 6 over 2, which again reduces to 3 over 1. Okay, write an equation to relate the ounces of water to the scoops of formula. So again, equations start off y equals. Okay, and then our unit rate, that's where we put that number in front of the x. So we're going to have an x on there, but our unit rate goes in front. So right here, this 3 over 1, but because it's 3 over 1, I'm just going to say 3. So an equation doesn't need the labels for the word problems. It's just straight up variables, numbers, no labels. So y equals 3x. Okay, and letter E. How many scoops of formula must Vanessa use to make a 9-ounce bottle for her baby? We see up here 9 ounces, and we had to have 3 scoops. So we'll say 3 scoops.